because I think you guys might even care about this. The key to knowing how to run this thing is why you should care about it. I mean, I gave you a program. Yes, yay, it's a gift. But if you don't see why we actually care about using it, it becomes a bit of a like, okay, it's great. It's like Angry Birds at this point. I'm not really gaining anything from it except the ability to throw birds to the air and knock pigs over. So, I mean, honestly. So let's look at what I would call a backwards problem. Okay, let's look at what I would call a backwards problem. So suppose we draw the bell curve. We slap a 0 in the middle. I always like having that in the middle, and you'll see why as soon as I ask you about some IQ scores momentarily. You'll see why I like to have that 0 in the middle. Okay. So let's suppose I asked you to find the z-score that traps the lowest 15% of the area on the curve. Now, you know what? Let's make it 10. Let's make it 10. So I want to know what z-score traps 10% of area to the left of it, which would conversely, of course, mean that 90% of the area is to the right of it. It's a dividing line. And that's one thing we have to get used to right now. And this comes back to what Jada said earlier, I believe, or Jenny. One of the two of you brought up a very, very good point earlier. I forget who it was exactly. But when you put a dividing line in a bell curve like this, and I say there's 10% below it, that means there's 90% above it, because it has to sum to 100%. That means the line itself doesn't actually account for anything. Right? Because it can't. You can't go over 100%.
That's just the dividing.
It's the dividing line, exactly. Because that line is infinitely thin. It's not like a probability in a discrete distribution. A probability in a discrete distribution actually has a chunk. Remember, for four girls out of 4 birds, it was 0.6561. For 2 girls out of 4 birds, it was 0.0486, and so forth. It actually had some stuff to it. It's just a dividing line. 10% is below, 90% is above. So let's figure it out. Let's figure it out. This is a backwards problem, and the key to know this is a backwards problem is what? What have I given you?
The percentage.
I've given you the percentage, I've given you the area, and I have not given you the z-score. I'm asking you to find the z-score. Mm-hmm. That's what makes it a backwards problem. Okay, so let's go ahead and run it. It's backwards. Which way does the area shade?
Left.
I've drawn the shade left. We'll do it both ways because you can actually shade it right if you wanted to. We'll do it left though, for sure. What percent has been shaded to the left?
10.
Good. Make sure you put it as a decimal though, otherwise the program gets pissed.
Oh, yeah.
0.1, it gets pissed if you put in 10 because that thinks it's 1,000%, and that doesn't make any sense. Here we go. It's going to draw it for you. There it is. And you got to go out to negative 1.28. That's the z-score. That's the z-score that traps. That's the z-score that traps 10% below it. So you have to go out, basically it's the left tail of 1.28 standard deviations. That's all that is. It's the left tail of 1.28 standard deviation. So we can actually take this a little bit further. If I put a line over here at positive 1.28 and shade it above that, if I shaded above that though, strictly above it, maybe it would be 10%, wouldn't it? Which then, how much area would I have between them? 80%. It's kind of cool, huh? So you get all that for free. Once you know this, you can reflect that over the axis of symmetry and use those areas and you always have your TI do this for you. You always have your TI do this for you. Please realize that. But it's nice to have that kind of mental suppleness with the curve to know that you can do that kind of flip-flopping back and forth.
It doesn't matter. You've told before. It doesn't matter if the 0 is in the middle or it can be 5.5.
We're going to do lots of things. Give me 15 minutes. We're going to start putting different numbers in the middle. We have to.
Okay.
We have to because of context. Mm-hmm. I can't think of anything in the world that has an average of 0 and a standard deviation of 1. Doesn't make any sense. So we have to put different numbers in.
And it doesn't matter if it's not symmetrical or symmetrical.
Oh, these will always be symmetric.
Okay.
And
okay.
Again, we'll be 15-ish minutes or so. Cool enough? Mm-hmm. Okay, so there are some, what percentile would that be? What, if I asked you, let me make sure I'm going to say this correctly. On your exam, I just said, what is the 40th percentile based on the, right? So for this one, number 2, I want to ask you a question you already know the answer to. What is the 10th percentile. And you know the answer to this already. You know the answer to this. It's negative 1.28. It's negative 1.28. Doesn't it have to be? It has to be negative 1.28 because that's the z-score below which 10% of the area is.
So if you said what's 90th percentile, be positive?
Read my mind, Gina. Read my mind. Gina, read my mind. She said, what's the 90th percentile? And that would have to be positive 1.28. Let's make sure we understand why. Let's make sure we understand why. It's based on what Mimi just said. Mimi just said if I put a positive 1.28 out here, that would mean that there would be 10% above it, which means that 90% is below it. It's the 90th percentile. Fair enough? Let's ask one you don't need your TI for. What's the 50th percentile? What's the 50th percentile? It's got to be 0. It's got to be 0. It's right in the middle. I mean, half the curve is left, half the curve is right. I mean, that's exactly the definition of what a median is. Or an average in this case, but median by strict definition of 50th percentile. Awesome. Now here's where I want to re-answer Jada's question from before. What is the first quartile for this curve? What is the first quartile for this curve? What is the first quartile? Now, again, I know the TI is doing a lot of this work for you. I kind of like drawing it still. I kind of get a rough sketch so you know what to put into the TI, because the TI is not going to, the TI will answer whatever question you ask it to answer, even if you ask it the wrong question. So let's draw what this is going to look like, okay? Here's a bell curve. There's 0 in the middle. Pretend it's a bell.
25%, should be 25%.
Good. So which side of 0 is the line I'm going to draw going to be on? Jenny's voting for left?
Yeah.
She's voting for left somewhere over here? Yes? So that's going to be a z-score. The problem is I don't know which one it is. But I do know what. 25% is where?
It's
To the left of this mark is 25% of the area.
and 75.
Exactly, 75 to the right, exactly. We can actually answer it both ways.
Yeah.
You only need one of those two to get that z-score. Because if you put in shades left 25% or shades right 75, you'll get the exact same result. So that's all we need. Do you see how, friends? This is the same question essentially as this one. Minus that, we did that the extra we did. But essentially that's the same question. It's just that I only asked it by saying what's the first quartile. Although I could have asked down here what's the 10th percentile. Same exact question.
Third quartile.
And we'll do that one too. We'll do the third quartile as well. What's the 75th percentile? But once you know what the first quartile is, you'll automatically know what the third quartile is because we're familiar with the curve now. Let's find it. Let's find it. Okay. More problems? Forwards or backwards?
Backwards.
Still backwards. Still backwards. Which way was shading? Definitely left. Percent is 0.25. It's going to draw it for us. Here she comes. I didn't draw it very well at all. I drew mine too far to the left on my curve. Your z-score is roughly negative 2/3.
So that's Q1.
That's Q1. Q1 is negative 0.67. That's how many standard deviations you'd have to go out to be in that first quartile. Yeah, David?
Mine's not wanting to do that.
Let me see. We could have to re-upload it. Let me just see real quick.
I can do it the other way, right, and 90, we did the last problem.
Absolutely.
But we get it.
Oh, yeah, you got to do somehow and insert it. Let me see if I can. You hit 1 bar stats. Let me just re-upload it. Oh, nobody fixed it actually. At some point you hit 1 bar stats. But that's okay. It's an easy fix. You somehow managed to insert the phrase 1 bar stats into my code. But I think we're good now. I think if it's not behaving like ours every single time though, that means there's something else corrupted. But we can fix it. It's an easy fix. You got it, man. You got it. Now, friends, of course, you could answer this question another way because of what Elena said. She said 25% shades to the left. Well, that also means that 75% shades to the right. So rerun it as a backwards problem, shading right 75%. Although you already know what the answer is going to be. Here she comes. Has to be the same thing, doesn't it?
Because, yeah.
The same z-score that keeps 25% to this side has to also keep 75% to this side. It has to be the dividing line between. It's 100% under the entire curve. 100% under the entire curve. So when you slap in one that traps 25 here, it's got to trap 75 here. Does that ish make sense?
Yeah.
That's not the 75th percentile, it's the 25th percentile. But it traps 75% above. And the reason I bring this up is because when you actually read things in research journals, you'll often hear things like the top 10%, the top 15%, the top 5%. So your mind has to be supple with, okay, top 5 means bottom 95. Top 10 means bottom 90. You have to kind of keep that kind of symmetry going in your mind, or that kind of complementary idea in your mind. Ready for this? You now know that Q1 is negative 0.67. Exactly. Bueno, ¿dónde está mi tequila? What is all this Spanish I learned watching The Simpsons years ago? What is Q3? No TIs, please. No TIs, please. Jen, help me out. Positive 0.67. Doesn't it have to be? Doesn't it have to be positive 0.67? Why?
From that.
Yeah. I'm going to switch back to my other shaded curve. I'm going to switch back to my other shaded curve to get a better image. So it shades to the left, 0.25. Okay, so here, oops. Okay. So I know, trillion, negative 0.67, and this is 25%. That's 25%. Fair enough? Fair enough. So if I take that negative 0.67 and I slap it symmetrically over on this side, make it positive 0.67, and then I shade to the right of that, well, that has to be 25% too, doesn't it? To the right. Because it has to be symmetrically equal on both sides. And if that's 25% on that side, that means it's 75% all the way down. And that's the 75th percentile, isn't it? And that's kind of slick. You also get exactly how much? 50% within within 2/3 of a standard deviation. That's one of those ones. Remember I told you years ago, i.e. 6 weeks ago, maybe not even that far. Feels like years, I know. Within one standard deviation, hell, you quoted me today, 68% within one standard deviation, 95% within two, and like almost 100 within three. This isn't even it's a more logical one. Half the data is within 2/3 of a standard deviation. Kind of slick, huh? Kind of slick. So there you go. Believable-ish? Cool. So those are forwards and backwards problems. Forwards, you have the z's, you're going for the probabilities, and backwards is vice versa. Now the next question. Why do we care? Why do we care? So I'm going to pause here.